Hello everyone. Settle in, get comfortable, and prepare for a journey to the very edge of the known universe. Picture the silence of deep space. But it's not an absolute void. It's a vast ocean filled with the whisper of stars, the hum of galaxies, and faint signals that have traveled millions of years just to reach us. We've learned to listen to this cosmic chorus. But what if a dissonance has appeared in this eternal symphony? What if someone or something is deliberately tampering with these signals, distorting the messages coming from the depths of space? Today we won't just discuss the search for extraterrestrial life. We're talking about an unsettling anomaly, one that forces scientists to ask, are we truly alone in the universe, or is someone trying to hide the truth from us? This is a discussion about mysterious radio interference, about cosmic enigmas that could completely change our perception of reality. Are you ready to hear what's hidden beneath the cosmic static? Then let's begin our deep dive. Before we dive into the world of anomalies, let's understand how we learned to listen to the cosmos in the first place. It didn't start with the hunt for aliens, it began with a rather mundane task. In the early 1930s, a young engineer named Carl Jansky, working at Bell Telephone Laboratories, was assigned to find the source of static noise disrupting transatlantic radio-telephone communications. He built a massive rotating antenna, which colleagues quickly nicknamed Jansky's carousel. Day after day, he catalogued various sources of interference. He identified noise from nearby storms, noise from distant storms, but one type of static behaved very strangely. It was a faint, continuous hiss that appeared in his headphones every 23 hours and 56 minutes. Astronomers know this interval well. It's the duration of a sidereal day, the time it takes Earth to complete one rotation relative to the stars, not the Sun. Jansky realized the source wasn't terrestrial, it was moving with the stars. By tracking it, he determined that the mysterious hiss originated from the very center of our galaxy, the Milky Way. And just like that, radio astronomy was born entirely by accident. We understood that the universe is filled not just with visible light, but with radio waves. Stars, galaxies, nebulae, they all emit in the radio spectrum. So we built giant ears, our radio telescopes, to listen to this music of the spheres. We learned to distinguish between natural signals, the steady drone of pulsars, the bursts of quasars, and artificial, man-made interference. But it is precisely at the border between the known and the unknown, hidden within the crackle of cosmic static, where the most intriguing mysteries lie. So, we started listening to the cosmos. And almost immediately, it began serving up mysteries. One of the most famous, and still unsolved to this day, is the signal known simply as WOW. Picture a warm summer night, August 15th, 1977. Astronomer Jerry Emmon was volunteering for the Search for Extraterrestrial Intelligence Project, SETI, at the Big Ear Radio Observatory at Ohio State University. His job was simply sifting through printouts of the data the telescope had gathered over several days. It was incredibly monotonous work. The data usually showed nothing but the universe's background noise, appearing as endless rows of 1s, 2s, and 3s on paper. But that day, as Emmon was reviewing the sheets, he stumbled upon an anomaly. On one page, he saw a sequence of characters that stood out starkly: 6, IQJ, 5. In the telescope's coding, numbers and letters represented signal intensity. This particular sequence indicated an extremely powerful narrowband signal that lasted exactly 72 seconds, the precise amount of time required for the Big Ear telescope's field of view to sweep across a stationary source in the sky. The signal was 30 times stronger than the background noise and possessed all the hallmarks astronomers would expect from an artificial, extraterrestrial source. It was narrowband, meaning it was transmitted on a very specific frequency, which is highly unusual for natural phenomena. Crucially, this frequency, 1420 MHz, is known as the hydrogen line. This is the frequency of radiation emitted by neutral hydrogen, the most common element in the universe. Many scientists believe this is exactly the frequency a technological civilization would use to initiate contact, a kind of universal cosmic channel. Stunned, Emmon circled the anomalous sequence with a red pen, and scribbled the now famous word in the margin, "Wow." That single exclamation mark ensured the signal went down in history. It felt like the moment humanity had been waiting centuries for: first contact. Scientists immediately aimed the Big Ear and other powerful telescopes around the world toward the exact point in the sky, in the constellation Sagittarius, where the signal originated. But they heard nothing. Absolute silence. They returned to that patch of sky dozens, then hundreds of times, but the "wow" signal never repeated. It was a singular shriek in the cosmic night, heard just once. What was it? Over the ensuing decades, countless hypotheses were proposed. Some suggested it was a rare terrestrial phenomenon, perhaps a signal reflecting off space debris, or an unusual gravitational lensing event. Others floated more exotic versions, maybe a passing alien vessel, now far beyond our ability to detect. There was even a theory involving two comets passing through the telescope's field of view, creating a hydrogen cloud capable of generating such a burst. However, none of these hypotheses has ever fully and convincingly explained all the characteristics of the WOW signal. It remains utterly unique. It is the perfect candidate for an artificial transmission, yet without repetition, it will forever remain an intriguing anomaly, a ghost in the machine, a reminder that the universe is a far stranger and more mysterious place than we can possibly imagine. And this very elusiveness, this inability to confirm or refute its nature, makes it the perfect illustration of what it means to listen to the cosmos. We heard something, but we couldn't understand it, and we can't be sure we'll ever hear it again. The mystery surrounding the WOW signal provided a powerful stimulus for the development of programs dedicated to the search for extraterrestrial intelligence, or SETI. While the fundamental idea of actively seeking out our cosmic neighbors isn't new, it was really in the latter half of the 20th century that this concept transitioned from pure science fiction into a field of legitimate science. A young radio astronomer named Frank Drake was a true pioneer of this movement. In 1960, he organized the first ever dedicated SETI experiment known as Project Ozma. Using the 26-meter radio telescope in Green Bank, West Virginia, Drake pointed it toward two nearby sun-like stars, Tau Ceti and Epsilon Eridani. He monitored them specifically on the famous hydrogen line, hoping to intercept a structured, artificial signal. The project ran for several months, but sadly, nothing other than background static was detected. However, Project Ozma's significance wasn't in its results, but in the mere fact that it happened. It proved that the search for extraterrestrial civilizations was a viable scientific endeavor. A year later, while preparing for a SETI conference, Drake decided to systematize all the factors that determine the probability of detecting alien intelligence. This led to the creation of the famous Drake equation. While it looks complicated, the equation is essentially a straightforward formula designed to estimate the number of technologically advanced civilizations in our galaxy with whom we could potentially make contact. The equation considers 7 variables: the rate of star formation in the galaxy, the fraction of those stars that have planetary systems, the average number of habitable planets within those systems, the fraction of those planets where life actually arises, the fraction of those with intelligent life, the fraction of those civilizations that develop technology for interstellar communication. And finally, the most challenging and sobering factor, the average lifespan of such a civilization. The core problem with the Drake equation is that we only know the value of the first parameter with any certainty. All the others are, by necessity, educated guesses based on our current, very limited knowledge. Depending on the values you plug in, the result can swing wildly, ranging from just one, meaning only us, to millions of civilizations. But the equation itself is less a tool for precise calculation and more of a philosophical roadmap. It forces us to contemplate our place in the universe and the distinct steps required for life to achieve technological maturity. Beyond passive listening, humanity has also attempted active contact. The most famous example is the Arecibo message, transmitted in 1974 using the massive radio telescope in Puerto Rico. This was a graphical message, encoded in binary, containing information about our decimal system, key chemical elements, DNA structure, a human image, our solar system, and the Arecibo telescope itself. The message was beamed toward the globular star cluster M13, located 25,000 light-years away. This means that if anyone is listening out there, we won't receive a reply for at least 50,000 years. Therefore, it was more of a symbolic gesture, a demonstration of our technological capability and our desire to announce our existence. SETI programs continue today, becoming increasingly complex and expansive. We are simultaneously monitoring millions of star systems and analyzing massive datasets using artificial intelligence, but so far, silence. This vast cosmic silence known as the Fermi paradox. If the universe is so abundant with civilizations, then where is everyone? Is one of the main driving forces behind our search, and it compels us to ask, are we looking for the wrong things or in the wrong places? Or, more intriguingly, perhaps the signals are there, but we simply cannot recognize them due to some strange, currently incomprehensible interference. The history of radio astronomy is packed with moments where scientists believed they were on the verge of the biggest discovery in human history, only to find something entirely different, yet equally astounding. Perhaps the most famous example occurred in 1967 at Cambridge University. A young PhD student named Jocelyn Bell Burnell was working on a project studying quasars, extremely distant and bright galactic nuclei. To do this, she and her supervisor, Anthony Hewish, built a new radio telescope that covered an area equivalent to 57 tennis courts. Jocelyn's job was the grueling routine analysis of miles of paper charts spat out daily by the recorder. But one day, scanning a fresh batch of data, she spotted something strange. Amidst the usual chaotic noise was a very short, repeating signal, appearing as a barely noticeable smudge on the strip. It was too fast and too perfectly regular to be a quasar. It pulsed with uncanny precision every 1.33 seconds. At first, the team suspected interference from a terrestrial source, maybe a faulty car ignition or malfunctioning electrical equipment. But checking the source confirmed it moved across the sky alongside the stars, meaning its origin was definitively cosmic. The signal was so regular, so seemingly artificial, that the team jokingly dubbed it LGM-1, short for Little Green Men. For a while, they seriously entertained the hypothesis that this might be a beacon from an extraterrestrial civilization. Anthony Hewish even worried about how to break the news to the world without causing panic. He understood that if this truly was alien life, the discovery would have colossal consequences. Jocelyn Bell continued her meticulous work and soon detected 3 more similar signals coming from different parts of the galaxy. It quickly became clear that these were unlikely to be 4 separate civilizations who all decided to signal us simultaneously. Instead, they had stumbled upon a new, previously unknown class of astronomical objects. Soon, the true nature of these objects was established. They were pulsars, rapidly spinning neutron stars. These are the super-dense remnants of massive stars that exploded as supernovae. With a diameter of only a few dozen kilometers, they pack a mass greater than our own sun. They possess incredibly strong magnetic fields, which force them to emit narrow beams of radio waves from their magnetic poles. As the star rotates, these beams sweep across the sky like the light of a cosmic lighthouse. If Earth happens to be in the path of one of these beams, we register a short, strictly periodic pulse. The discovery of pulsars became one of the greatest achievements of 20th century astronomy. It confirmed the existence of neutron stars and provided a unique tool for studying matter in extreme states and testing Einstein's general theory of relativity. For this discovery, Anthony Hewish received the Nobel Prize in Physics in 1974. Unfortunately, Jocelyn Bell, who had actually made the crucial initial detection, was controversially excluded from the award, a decision that still sparks debate in the scientific community today. But the story of the Little Green Men served as a critical lesson for all hunters of extraterrestrial signals. It showed that the universe is capable of producing phenomena that mimic, with uncanny accuracy, what we might consider signs of intelligence. Nature proved far more ingenious than we could have ever imagined. And this lesson demands extreme caution when we encounter a new anomaly. Before shouting aliens, we must first rule out every possible natural explanation, even the most exotic ones. Drawing on past experience, modern radio astronomy has encountered a new mystery, one that might just eclipse the famous WOW signal and even the discovery of pulsars. This puzzle is called fast radio bursts, or FRBs for short. The story of their discovery, like so much in this field, began purely by accident. In 2007, astronomer Duncan Lorimer and his student David Narkovich decided to re-examine archival data collected by Australia's Parkes Radio Telescope back in 2001. They were searching for new pulsars but stumbled upon something entirely different. It was a single, immensely powerful radio pulse that lasted only a few milliseconds, less than the blink of an eye. Yet in that tiny fraction of time it released as much energy as our Sun produces over several days. Analyzing the signal revealed another oddity. It was highly dispersed. This means the high-frequency waves arrived slightly earlier than the low-frequency waves. This effect happens when radio waves travel through the interstellar medium, which is filled with free electrons. The further away the source, the greater the dispersion. The dispersion of this signal, later dubbed the Lorimer burst, was so massive that it pointed to a source far outside our galaxy, potentially billions of light-years away. This was something completely new and utterly inexplicable. For several years, the Lorimer burst remained a singular event. Many astronomers were skeptical, suggesting it might have been a fluke, a rare equipment error, or misinterpreted terrestrial interference. However, in 2012, the Parkes telescope recorded several more such events. It became clear that fast radio bursts were a genuine astrophysical phenomenon. Since then, thanks to new, more sensitive telescopes like Canada's CHIME, we are detecting hundreds, if not thousands, of FRBs every year. We've learned more. We know they arrive from all directions in the sky, confirming their extragalactic origin. We also know some of them repeat, firing pulses from the same spot, while others flash only once and then go silent forever. In 2020, a major breakthrough occurred. Astronomers were finally able to pinpoint the source of an FRB within our own galaxy. The culprit was a magnetar, a special type of neutron star with an extremely powerful magnetic field. This discovery provided strong evidence that at least some FRBs are generated by magnetars. Perhaps powerful surface flares, a kind of starquake, are responsible for triggering these colossal bursts of radio energy. However, the puzzle is far from solved. The magnetar model cannot explain all the observed FRB characteristics. For instance, why do some of them repeat with strict periodicity? One of the most famous repeaters, FRB 121102, bursts actively for 90 days, then goes silent for 67 days before the cycle repeats. Such rigid behavior is difficult to attribute to the solitary activity of a magnetar, and naturally, when a mystery of this magnitude appears, bolder hypotheses take the stage. Some scientists have speculated that FRBs might not be a natural phenomenon at all. Could this be a techno-signature? Perhaps a byproduct of super-powerful engines from alien spacecraft traversing between galaxies? Or maybe they are purposeful signals, energy beacons placed by an ancient civilization for navigation or communication across intergalactic space. For now, this is pure speculation, but the sheer power and brevity of these signals make them incredibly intriguing. They seem to challenge us, demonstrating physical processes we cannot yet fully comprehend. It is in this grey area between the known and the unknown that the idea is born, that we might be witnessing not just a natural cataclysm but something deliberately engineered, and perhaps even distorted by design. Let's talk about the elephant in the room, or perhaps more aptly, the microwave in the staff kitchen. Before jumping to theories about galactic lighthouses and alien propulsion systems, every radio astronomer must first contend with a far more terrestrial problem, radio frequency interference, or RFI. Our planet is an incredibly noisy place in the radio spectrum. Cell phones, Wi-Fi routers, satellites, TV and radio broadcasters, radar systems, even household appliances, they all create a powerful noise floor that can easily drown out faint signals from deep space. Radio telescopes are extremely sensitive instruments designed to pick up signals billions of times weaker than the signal your cell phone emits. This makes them incredibly vulnerable to terrestrial interference. Observatories are usually built in remote, sparsely populated areas, in what are known as radio quiet zones. where the use of many electronic devices is legally restricted, but even this is often not enough. The history of radio astronomy is littered with amusing cases where mysterious cosmic signals turned out to be entirely earthly phenomena, but perhaps the most illustrative story of all occurred at the very same Parkes Observatory in Australia. Starting in 1998, the telescope began registering strange, short radio bursts they dubbed peritons. They resembled fast radio bursts, but unlike them, they seemed to originate not from deep space, but somewhere within Earth's atmosphere. They appeared at random times, and their nature remained a mystery for 17 years. Scientists racked their brains, proposing everything from upper atmospheric lightning to unknown atmospheric phenomena. The periton mystery was actually one of the main reasons the astronomical community was so slow to accept the reality of FRBs. What if those too were just local interference? The solution arrived in 2015, and it was simultaneously hilarious and elegantly simple. A team of astronomers installed a new interference monitoring receiver on the telescope. It quickly noted a key pattern. The peritons only appeared during working hours, specifically around lunchtime. Furthermore, the new receiver logged the bursts at 2.4 GHz, the operating frequency of a standard microwave oven. After investigating, they discovered the observatory kitchen housed 2 old microwave units. When a staff member opened the oven door before the cycle had fully finished and the magnetron had powered down, it emitted a brief radio pulse. This impulse was then picked up by the hypersensitive telescope. Ta-da! The mysterious peritons turned out to be nothing more than impatient astronomers reheating their lunch. This story is a perfect illustration of Occam's razor in science. The simplest explanation is usually the correct one. It underscores the critical importance of ruling out every possible terrestrial source before announcing a cosmic discovery. Modern observatories employ sophisticated algorithms and filtration systems to weed out RFI. They compare signals from different telescopes, look for correlations with known satellites, and analyze signal arrival times. But even with all these precautions, the possibility remains that some new, as yet unknown type of terrestrial interference could be mistaken for something much bigger. And this brings us to the central question of today's discussion. We've learned to distinguish natural cosmic noise from our own terrestrial noise quite well. But what if there is a third type of signal? What if someone else is creating the noise? And what if that interference isn't accidental but intentional? This is where we step into the territory of the boldest, most audacious, and currently unprovable hypotheses. We've already covered natural anomalies like the wow signal and extreme but natural phenomena such as fast radio bursts. We've also addressed the issue of Earth-based interference. Now let's take the next step and ask ourselves, what if some or even all of these anomalies are part of something much larger, something non-human? What if someone or something is actively interfering with the radio signals we receive? The first, and perhaps the most benign version of this interference, is the idea of a galactic internet. Imagine our Milky Way galaxy populated by countless, highly advanced civilizations. If they've existed for long enough, they would almost certainly have developed a way to communicate across interstellar distances. It's possible they have established a communication network spanning the entire galaxy. In this model, fast radio bursts, or FRBs, might not be random natural cataclysms. They could be data packets being transmitted across this network. We, as a young and technologically primitive civilization, are merely intercepting these packets by accident, unable to decipher them. To us, they register as meaningless noise, like trying to download a modern streaming website using a dial-up modem from the 1990s. The periodicity of certain repeating FRBs in this hypothesis could be explained by the fact that we lie in the path of regular traffic, perhaps between 2 major nodes in this network. The signal source might be rotating, and we only intercept its beam at specific, predictable times. This idea is highly speculative, of course, but it elegantly accounts for many of the peculiarities of FRBs, their immense power, their brevity, and their extragalactic origin, assuming such a network could even be intergalactic. In this scenario, the interference isn't directed at us. We are merely incidental eavesdroppers standing outside a closed door, unable to comprehend the language inside. We see the light flash from vehicles speeding along an information superhighway, but we can't read their license plates. This makes the universe feel far less lonely, but it also underscores our technological isolation. We simply haven't matured enough to be invited into this galactic club. We are still sending smoke signals while everyone else is running on fiber optics. This hypothesis also suggests an entirely new approach for SETI, the search for extraterrestrial intelligence. Instead of looking for simple, deliberate hello signals, maybe we should be searching for complex, structured communications that were never intended for us. This is a vastly more difficult task, requiring new data analysis methods. We must learn how to distinguish a meaningful yet alien signal from pure natural chaos. Perhaps the key to the mystery already lies within our data archives, but we simply don't know how to look for it. We're searching for a simple hello, yet they are broadcasting all of war and peace in a language we don't understand. So the first possible explanation for these anomalies isn't hostile intervention, but rather the unintended side effect of civilizations so far ahead of us that they don't even notice our existence. Their exhaust fumes, so to speak, are for us the greatest mystery in astrophysics. And that is perhaps the most optimistic of all the speculative scenarios. Let's explore the second, more complex and intriguing hypothesis of intervention. What if the signals we receive aren't entirely artificial, but are actually modified natural phenomena? Imagine a civilization so advanced that it is capable of manipulating fundamental astrophysical objects. For such a civilization, it would be far more energy efficient not to build gigantic transmitters from scratch, but instead to use the powerful, existing energy sources in the universe, for instance, pulsars or magnetars. In this model, a fast radio burst might be initiated by a natural process, such as a starquake on a magnetar, but then before that signal travels across the cosmos, it passes through some kind of technological device that modulates it, essentially embedding information into the very fabric of the wave. This is similar to how we modulate a radio wave to transmit music or speech. The carrier wave itself might be simple, but the information it carries is complex. This approach has massive advantages. First, the energy savings are colossal. The civilization doesn't need to generate power equivalent to the sun, it simply harnesses what's already available. Second, to less developed civilizations like ours, such a signal would appear almost indistinguishable from a natural phenomenon. We observe a powerful burst, note its natural characteristics, and most scientists would simply conclude it's just a magnetar. Only a meticulous analysis of the signal's fine structure, its polarization, and microsecond variations could possibly reveal a hidden message. This is the perfect method for covert communication, or for creating a beacon that attracts the attention only of those who have reached a specific level of technological maturity, those capable of reading between the lines of cosmic phenomena. This idea also resonates with the ongoing debate within the SETI community regarding the nature of alien signals. There are two main camps, the beacons proponents and the eavesdropping proponents. The beacons camp believes that an advanced civilization wanting to announce its presence would create a very simple, obvious, and easily detectable signal, a kind of cosmic "hello, we're here." This would be a narrow band, powerful, perhaps repeating signal that is impossible to mistake for a natural event. The wow signal, if it were to repeat, would be a prime example. The eavesdropping proponents, however, argue that we are more likely to detect not deliberate messages, but leakage from their internal communications, radar systems, or the byproducts of their technology, just as an alien civilization might detect us via the broadcast radiation from our television stations and military radars. The hypothesis of modifying natural signals offers a third, middle path. It could be both a beacon and covert communication simultaneously, a beacon expertly disguised as a natural phenomenon. To find it, you don't just need to listen, you need to know exactly what and where to look. It's like finding a secret message written in invisible ink on the page of an ordinary book. You won't see it unless you shine a UV light on the page. In our scenario, the UV light is the application of new data analysis techniques and a deep understanding of astrophysics. If this hypothesis holds true, we might have been receiving these messages for decades without even realizing it. They are lost in the sheer volume of data, dismissed because we mistake them for mere cosmic noise. This means the answer to humanity's biggest question could already be in our hands, yet we haven't learned how to read it. That is both an exhilarating and slightly disheartening thought. Now we approach the most disturbing and bleak scenario. What if interference with cosmic signals isn't just a side effect of alien activity or a hidden friendly beacon? What if it's intentional, hostile, or at the very least, driven by fear? This brings us into the realm of the dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, though the concept was debated in scientific circles even before him. This hypothesis offers a chilling answer to the Fermi paradox, the question of why we see no signs of other civilizations. The answer is simple. The universe is a dark forest. In this forest, every civilization is an armed-to-the-teeth hunter, creeping silently between the trees, desperate not to make a sound. Why? Because there are other hunters out there. If you detect other life, you cannot be certain of its intentions. Is it friendly? Is it hostile? You can never know for sure. Any contact is a colossal risk. And what if the other civilization is technologically superior to you? Then you become either a potential threat that must be eliminated preemptively, or simply a resource to be exploited. When interstellar distances make meaningful communication and understanding virtually impossible, the safest survival strategy is silence, and the immediate destruction of any other life you discover before it discovers and destroys you. In this context, discovery equals annihilation. This is why everyone remains silent. Anyone who reveals their location will be instantly wiped out by the nearest, more advanced hunter. In this context, any broadcast into space, any message like the Arecibo message, is an act of absolute madness, a death sentence already traveling toward us at the speed of light. If the dark forest hypothesis holds true, it completely transforms our understanding of radio anomalies. Interference with signals could serve two main purposes. The first is camouflage. An advanced civilization might intentionally distort or destroy its own technosignatures, making them sound like natural static to avoid drawing attention. They could employ sophisticated technology to make their planet and star system appear utterly lifeless and uninteresting in the radio spectrum. The second, and far more ominous purpose, is active suppression of others. Imagine a super predator in this forest, a civilization so advanced it monitors vast swaths of the galaxy. If it discovers the birth of a young technological civilization that starts making noise in the radio spectrum, as we have for the last 100 years, it might not physically destroy it. It might just silence its signals. It could create powerful jamming or distortion fields so that other hunters don't notice this young civilization. Why? Perhaps to reserve it for itself as a future resource, or simply to enforce radio silence within its galactic sector. In this scenario, fast radio bursts, for instance, could be the shots of a cosmic sniper intended to blind or disinform observers. The anomalous signals we can't explain might be echoes of this hidden war, or the actions of a galactic police force maintaining order and silence. This hypothesis is undoubtedly the most pessimistic. It paints a picture of a universe that is not merely empty, but rife with hidden fear and profound threat. It transforms our noble quest for contact into a deadly gamble, and it forces us to re-examine the great silence of the cosmos. Perhaps it is not the silence of emptiness. Perhaps it is the silent, held breath of those who know the rules of the game and are terrified to break them. Having looked at the bleak prospect of the dark forest, let's turn back to ideas that are more scientific and less speculative, yet still undeniably strange. One such idea suggests we might be witnessing the activity of civilizations far beyond our own, specifically what are known as Type 2 or even Type 3 civilizations on the Kardashev scale. This scale, proposed by Soviet astrophysicist Nikolai Kardashev in 1964, classifies civilizations based on the sheer amount of energy they are capable of harnessing and utilizing. A Type 3 civilization is a planetary civilization, one capable of utilizing all the energy available on its home planet. For the record, we haven't even reached this level yet. We currently clock in at about 0.73 on the scale. A Type 2 civilization is a stellar civilization that has learned to control and exploit all the energy output of its host star. The classic example of this technology is the Dyson sphere, a hypothetical megastructure that completely envelops a star, capturing all its emitted radiation. Finally, a Type T3 civilization is a galactic civilization capable of harnessing energy on the scale of an entire galaxy. The activities of such mega-civilizations should be visible across vast distances, but not necessarily in the form of simple radio messages. Their techno-signatures would be far larger and much stranger. For example, a Dyson sphere built around a star would make it invisible in the optical spectrum. However, the sphere would become a powerful source of infrared radiation, essentially the waste heat that the megastructure dumps into space. Therefore, one method for searching for these civilizations is to look for stars with an abnormally high infrared excess. And we do have candidates. The most famous is Tabby's star, or KIC 8462852, which exhibits strange aperiodic dips in brightness that are difficult to explain by natural phenomena alone. But how does this relate to radio signals or interference? A Type 2 or Type 3 civilization operating with energies on stellar and galactic scales could create side effects that we perceive as anomalous radio signals. Imagine the process of stellar engineering, modifying a star's characteristics, moving stars, or even deliberately initiating supernova explosions to synthesize desired elements. The energetic processes accompanying such activity would be colossal. They could generate bursts of radiation across all spectra, including radio. To us, these bursts would look like inexplicable, super-powerful, possibly repeating events that we try to explain using our existing astrophysical models, magnetars, neutron star collisions, and so on. But in reality, this might simply be the industrial hum of a galactic civilization. In this scenario, the interference is again not aimed at us. We are like ants living at the base of a skyscraper under construction. We hear the rumbling, feel the ground shake, see the flashes of welding, but we cannot comprehend that this is part of a coherent construction process. To us, these are just random, frightening cataclysms. This hypothesis explains why we aren't receiving simple greeting signals. A civilization capable of building Dyson spheres has likely moved on to far more sophisticated methods of communication, perhaps using gravitational waves or even phenomena our physics hasn't discovered yet. Radio communication for them is like cave painting is for us. They aren't trying to contact us using such a primitive method. Everything we detect is just a faint echo of their colossal operations. Searching for these massive techno-signatures is one of the most promising avenues in modern SETI, the search for extraterrestrial intelligence. It forces us to expand our imagination and look not just for little green men, but for the footsteps of galactic engineers who are reshaping the face of the universe without giving us a second thought. Another hypothesis that attempts to explain these strange radio signals plunges us into the realm of even more fundamental physics and cosmology. This one involves what are known as cosmic strings. These are hypothetical, one-dimensional topological defects in space-time believed to have formed during the universe's earliest moments, right after the Big Bang. Imagine freezing water in an ice tray. As the water solidifies, ice crystals form, growing outwards from different points. Where the boundaries of these growing crystals meet, defects like tiny cracks can arise. Cosmic strings theoretically are similar phenomena, but scaled up to the entire universe. They are relics of the early universe's phase transitions. If they exist, these strings would be unbelievably thin, perhaps narrower than a proton, yet they would possess colossal mass and tension. They could stretch for vast distances, potentially traversing the entire observable universe. They are predicted to move through space at near-light speeds and can form closed loops. So, why are they relevant to our discussion? The interaction of these cosmic strings with matter and radiation should generate unique, observable effects. For instance, when a string oscillates or crosses itself, it might emit powerful bursts of gravitational waves. But there's more. Theory predicts that under certain conditions, specifically when cusps, sharp kinks on the string, are formed, the string could emit extremely powerful focused beams of electromagnetic radiation, including radio waves. Some scientists have hypothesized that fast radio bursts, or FRBs, could be exactly these events. A signal from a cosmic string cusp would be extremely short, incredibly powerful, and originate from cosmological distances, a perfect match for the observed properties of FRBs. If the source is an oscillating loop, the bursts might even repeat. Furthermore, this hypothesis might solve other puzzles. Cosmic strings should act as gravitational lenses, but with peculiar characteristics. They ought to create double images of distant quasars or galaxies without any visible intervening lensing mass. And interestingly, such twin pairs of objects seem to be genuinely observed. In the context of interference, cosmic strings are a textbook example of a natural phenomenon that could imitate an artificial signal with striking precision. If we were to register a series of perfectly periodic, powerful bursts from an oscillating cosmic string loop, we would almost certainly mistake it for the work of an extraterrestrial beacon. This brings us back to the great lesson learned from the discovery of pulsars. The universe is capable of tricks that can deceive even the most experienced observers. We might be searching for intelligence only to discover new, fundamental physics. This is certainly no less thrilling, but it is a very different story. There is also a more exotic version of this hypothesis. What if an advanced Type 3 civilization learned not just to observe, but to actively manipulate these cosmic strings? They could potentially use them like the giant strings of a cosmic harp, forcing them to oscillate at specific frequencies to create signals that could be transmitted across the entire universe. This would be the perfect transmitter, woven from the very fabric of space-time itself. In that scenario, we return to the idea of modifying natural, or in this case, primordial, phenomena. We detect a burst from a cosmic string, but we have no way of knowing if it was caused by natural processes or by someone actively plucking that string. As of now, the existence of cosmic strings remains purely theoretical, lacking solid observational confirmation, but the search is ongoing. If they are discovered, it won't just revolutionize physics, it will add a new, completely unexpected twist to our story about mysterious signals from deep space. Let's take a slight detour from exotic physics and refocus on the signals themselves. What qualities must a signal possess for us to confidently declare, yes, this is artificial? Scientists at the SETI Institute and other organizations have developed an extensive list of criteria. One of the most critical is the signal's bandwidth. Natural astrophysical sources typically emit radiation across a very wide frequency range. Think of the roar of a waterfall encompassing every possible tone. An artificial transmitter designed for communication, however, would likely use an extremely narrow band of frequencies. This allows it to concentrate all its energy into a tiny spectral window, making the signal stand out powerfully against the background noise. It's like hearing a flute over the rush of a waterfall. It's easy to isolate. The famous wow signal possessed exactly this characteristic. Its extraordinarily narrow bandwidth is what made it so intriguing. The second key criterion is the presence of modulation. Natural signals are usually chaotic, or they exhibit simple periodicity, like that of a pulsar. An artificial signal carrying information must be modulated. This means its characteristics, amplitude, frequency, or phase must change over time following a complex, non-random pattern. Deciphering that modulation is a subsequent step, but first we have to detect it. We are looking for complexity and order where we expect to find chaos. The third sign is the Doppler shift. Since the signal's source would most likely reside on a planet orbiting a star, we should observe a periodic variation in the signal's frequency. When the planet moves toward us, the frequency increases slightly. When it moves away, the frequency decreases. This Doppler effect will produce a complex curve, reflecting both the planet's rotation on its axis and its revolution around its star. Detecting such a complex Doppler drift would be very strong evidence that the source is planetary. The fourth criterion is signal polarization. Electromagnetic waves can be polarized, meaning their oscillations occur along a specific plane. Many natural sources, like pulsars, emit strongly polarized radiation, but an artificial signal might feature a very specific, complex type of polarization, for instance, circular polarization, which rarely occurs in a pure form naturally. Now, armed with these criteria, let's return to our central question. How might interference or modification show up in these characteristics? Imagine we receive a signal that appears almost perfect. It's narrow band and it has complex modulation, but there's something strange about it. Perhaps its Doppler shift doesn't align with the movement of any known planet, or perhaps its polarization changes chaotically, as if someone is trying to scramble it. Even more interesting, imagine we receive two signals simultaneously from the same point. One looks like a typical natural source, say a pulsar, while the second is a weak, complex, modulated signal superimposed upon it. This could be direct evidence for the very hypothesis we discussed, the modification of natural sources. Someone might be using a pulsar as the carrier wave for their own transmission. Or conversely, suppose we find a perfect artificial signal, but it periodically cuts out. It doesn't just fade, it vanishes as if something is actively blocking or jamming it. This could be a sign of super-predator activity linked to the dark forest hypothesis, someone trying to conceal the signal from other observers. Searching for these subtle anomalies and inconsistencies is the cutting edge of modern SETI. Scientists are no longer just looking for a signal. They are hunting for a signal within a signal trying not to be a signal, or a signal that someone is trying to obstruct. This requires powerful supercomputers and machine learning algorithms capable of sifting through petabytes of data in search of these elusive oddities. This isn't just listening to the cosmos anymore, this is true cosmic forensics, where we use the smallest clues to reconstruct the scene and determine who authored the message and who the mysterious editor might be. Let's look at another aspect of this problem that is often overlooked. We constantly talk about radio signals. But why radio specifically? It's simply because radio waves easily penetrate the interstellar dust and gas that normally block visible light, and they don't require super exotic technology to generate. We mastered radio communication over 100 years ago, so it's logical to assume that other civilizations started there too. But what if a truly advanced civilization long ago abandoned radio for far superior communication methods? This is known as the obsolete technology hypothesis. Perhaps we're looking in the wrong place for the wrong thing because we judge others by ourselves. It's like trying to find traces of a modern civilization by looking for smoke signals in the sky. Yes, it was once a primary way to communicate long distances, but today it is hopelessly outdated. What alternatives exist for radio? The first that comes to mind is optics, meaning lasers. A laser beam can be focused with incredible precision and aimed directly at a specific star system. Such a signal would be extremely energy efficient and difficult to intercept unless you are directly in its path. Optical SETI programs already exist. They search for very short monochromatic flashes of light coming from stars that might be laser pulses. So far, the results are negative, but the search continues. The second, more exotic alternative is neutrinos. These elementary particles barely interact with matter at all. They can fly straight through an entire star without even noticing it. This makes them the ideal unblockable information carrier. The problem is that neutrinos are equally difficult to detect. We have massive underground detectors, but they barely register the neutrinos coming from our own sun. Detecting a focused neutrino beam from an alien civilization is a challenge at the very limit of our current capabilities. The third possibility is gravitational waves, ripples in the very fabric of space-time. With the advent of gravitational wave observatories like LIGO and Virgo, we've gained an entirely new way to study the universe. An advanced civilization could theoretically learn to generate and modulate gravitational waves, creating a communication channel accessible throughout the entire cosmos. But how does this relate back to our initial topic of interference in radio signals? It's simple. If a civilization primarily uses, say, gravitational waves for communication, the radio band might become little more than a dumping ground or a byproduct of their core activities. Powerful processes that generate gravity waves, for instance, manipulating black holes or neutron stars, might simultaneously create colossal bursts of radio emission. In this scenario, these rapid radio bursts are not a structured signal or industrial noise. They are merely the cosmic exhaust from a gravitational wave engine or transmitter. This explains their immense power and their seemingly meaningless nature. Furthermore, if some complex activity involving multiple technologies is occurring at a single point in space, we might observe a very strange pattern. For example, we detect a powerful radio burst, followed shortly by a burst of gravity waves from the exact same location, and then perhaps a neutrino flash. This kind of multi-messenger event would be virtually impossible to explain using standard astrophysical models. It would be a strong indicator that something artificial is taking place, and this is where interference takes on a new meaning. Perhaps no one is intentionally interfering with our radio signals. Maybe we are only observing a single, primitive and dirty channel from a vast spectrum of communications. We are hearing the banging and crashing noises from a cosmic construction site, but we aren't seeing the blueprints or hearing the architects negotiating over the radio. This means that for a successful search, we need to develop multi-messenger astronomy and look not just for signals, but for correlations between signals across different spectra, from radio waves to gravitational waves. Only then can we build a complete picture and distinguish the truly strange from the merely misunderstood. When we discuss external interference, we usually assume it happens out there in the depths of space, and that we, here on Earth, are merely passive observers. But what if the truth is far more complex? What if someone, or something, is interfering not somewhere far away, but right here in our solar system, perhaps even in Earth's immediate vicinity? This concept is known as the alien probe, or sentinel hypothesis. According to this theory, an advanced extraterrestrial civilization, rather than dispatching costly and slow crewed expeditions, could deploy millions of small, autonomous, self-replicating probes across the galaxy. These von Neumann probes would hop from one star system to the next, using local resources to build copies of themselves, which would then continue the journey. In this way, practically the entire galaxy could be explored within a few million years, a negligible time frame on a cosmic scale. If such a civilization exists, it's highly probable that one or more of these probes have long since arrived in our solar system and are currently operating in observation mode. They might be hidden in the asteroid belt, on one of the gas giant moons, or even in orbit around Earth. Their primary mission would be to monitor the development of life and technology on our planet and potentially relay reports back home. Such a probe would likely strive to remain undetected. However, its activities might have observable side effects. For instance, to communicate with its base or other probes, it must use some form of transmitter. This signal could be extremely weak, highly directional, and deliberately complex to prevent our recognition. But what if this probe is not only observing but actively interfering? It might be attempting to edit the information we receive from space. Why? Perhaps out of concern for galactic quarantine. It could be blocking or distorting any signals from other civilizations to prevent us from discovering their existence. The goal of such a quarantine might be to allow our civilization to develop independently, free from external influence that could prove catastrophic. Or, conversely, the objective might be to conceal our existence from other, more dangerous civilizations, aligning with the dark forest scenario. The Sentinel probe effectively acts as a protective, yet strict, parent, shielding us from the dangers of the greater universe. In this reality, when we point our radio telescope skyward, we are not seeing a pure picture, but a filtered and edited version. Some signals simply never reach us. Others might be distorted, and certain anomalous signals might even be manufactured by the probe itself to divert our attention or steer our development along a specific path. This is admittedly a highly conspiratorial theory, and we have no direct evidence to support it. Searches for such artifacts in the solar system are ongoing, but have so far yielded no results. Yet this hypothesis forces us to question a fundamental assumption underlying all of radio astronomy. We assume the space between us and distant stars is empty and transparent. What if that is not the case? What if an invisible curtain hangs directly in front of our window to the universe, distorting the view? This shifts the problem of interference from cosmological distances right to our doorstep, making it far more complicated and confusing. We cannot be certain that what we perceive is what is truly there. And that, arguably, is the deepest and most unsettling form of intervention imaginable. Let's get back to solid ground and focus on the real, observable data. In recent years, thanks to the emergence of a new generation of ultra-sensitive telescopes, we've started gathering unprecedented amounts of information about the radio universe. And this data is constantly throwing up new puzzles that perfectly tie into the broader theme of intervention we've been discussing. One of the most fascinating discoveries has been the detection of what are called odd radio circles, or ORCs. These are gigantic, almost perfectly circular structures visible only in the radio spectrum, with diameters reaching up to 1 million light-years. Crucially, they have no obvious counterpart in the optical, infrared, or X-ray ranges. Only a handful of these objects have been found so far, and their nature is a complete mystery. Current theories range from being shockwaves resulting from the merger of supermassive black holes to the aftermath of exotic processes in the intergalactic medium. However, none of these theories fully explain their ideal geometry and the complete lack of a visible central object that could have created them. Naturally, bolder hypotheses immediately spring up. Could these be artifacts of mega-engineering, perhaps the footprint of a giant portal, or a byproduct of a propulsion system utilizing exotic physics? Their perfect geometry certainly suggests an artificial origin, although, as the history of pulsars taught us, nature is also quite fond of geometry. Another enigma involves the so-called repeating fast radio bursts with long periodicity. We've mentioned one of these before, but now several are known. They exhibit cycles of activity and silence that last for hundreds of days. Such behavior is very difficult to explain using a single object like a magnetar. One model proposes that the FRB source exists in a binary system, perhaps paired with a massive star or a black hole. In this case, the periodicity might be linked to orbital motion. The signal only reaches us when the source emerges from behind its companion or passes through a specific spatial region. But what if this periodicity isn't related to orbital motion? What if it's an engineered schedule? For instance, it could be a beacon that switches on by schedule to conserve power. Or perhaps it's a planetary defense system that periodically scans the sky with powerful radar pulses. And here, the idea of intervention resurfaces. If it is a radar, it might not even be aimed at us. We could just be accidentally catching its beam. However, its operation could cause interference or distortion to other, weaker signals passing through that region of space. We might see a distant quasar periodically flicker or change its characteristics because its light is passing directly through the powerful beam of an alien radar. Detecting such a correlation, a periodic FRB accompanied by the simultaneous distortion of background sources, would be virtually irrefutable proof of extraterrestrial technology. We don't have those observations yet, but this is an area where modern researchers are actively focusing their efforts. They are no longer simply cataloging anomalies. They are looking for connections between them, attempting to find a common cause for seemingly unrelated phenomena. They are trying to determine whether all these strange radio circles, periodic bursts, and isolated signals are separate mysteries, or if they are all pieces of one giant, incomprehensible puzzle, a puzzle depicting the activities of a mind so different from our own that we cannot yet even begin to grasp its motives or goals. Let's touch upon another aspect deeply connected to the psychology and philosophy of our search. It's what we call the anthropic principle, or, put simply, our inherent tendency to look for what resembles us. When we search for extraterrestrial intelligence, we are subconsciously looking for a reflection of ourselves. We hunt for carbon-based signals originating from Earth-like planets orbiting Sun-like stars. We seek messages encoded using the mathematics and physics as we currently understand them. Essentially, we are looking for little people, even if they happen to be green. But what if intelligence in the universe can take on completely alien forms? What if there is silicon-based life residing on searing hot planets, or gaseous intelligence floating in the atmospheres of gas giants, perhaps even plasma intelligence dwelling within the crowns of stars? Taking this idea even further, what if intelligence isn't bound to matter as we know it at all? Maybe it exists as a complex computational network leveraging quantum effects in interstellar gas. Or perhaps it is the collective consciousness of an entire star cluster. The techno-signatures of such civilizations would differ radically from anything we are currently searching for. They wouldn't be sending simple radio messages. Their communication and activity might be woven into the very fabric of astrophysical phenomena. For instance, a collective nebular intelligence could modulate its radiation, creating complex fractal patterns in the radio spectrum that we simply mistake for natural turbulence. Or a civilization residing inside a star might alter its pulsations, encoding information we dismiss as merely a strange type of variable star. In this context, interference isn't someone interrupting our signals, it's someone who is the signal. Their thoughts, their lives, their entire culture manifest as anomalies in the physical processes we observe. We try to separate the signal from the noise when in reality, the signal is the noise. We are looking for a needle in a haystack when the entire haystack is the needle. This completely flips our traditional SETI approach on its head. Instead of filtering data and discarding anything that resembles natural noise, we might instead need to scrutinize that noise, searching for hidden complexity, non-random patterns and signs of organization that stretch beyond our current understanding of physics. This is an incredibly difficult task, like trying to find a meaningful conversation in the sound of rain or the howling of the wind. Our brains simply aren't equipped for it. But perhaps artificial intelligence can help. Neural networks trained on vast astronomical datasets might learn to perceive the subtle, non-linear correlations that escape the human eye. Perhaps one day such an AI will analyze the spectrum of a distant quasar and deliver the verdict. Probability of artificial modulation, 99%. And then we will realize that all along we were looking directly at our conversational partner, but didn't recognize them because we expected to see a face, but instead saw a storm. This idea of non-human intelligence also offers a new explanation for the Great Silence. Maybe the universe isn't silent at all. Maybe it is shouting in 1,000 different languages, but we are deaf to every one of them except our own. And until we learn to tune our receiver to other forms of existence and consciousness, we will remain sitting in our small room, complaining about the quiet while a carnival rages just outside the window. Having considered countless theories from the strictly scientific to the purely fantastical, we inevitably arrive at one core question: what happens now? What practical steps is the scientific community taking to solve the mystery of anomalous radio signals and potential interference? The future of radio astronomy and SETI hinges on several key directions. The first is the construction of even larger and more sensitive telescopes. The Square Kilometre Array Project, or SKA, is arguably the most ambitious scientific undertaking in human history. It will be a colossal radio telescope made up of thousands of antennas spread across Australia and South Africa, boasting a total collecting area of about 1 square kilometre. When fully operational later this decade, the SKA will be 50 times more sensitive and capable of scanning the sky 10,000 times faster than any existing radio telescope. The SKA will be able to detect extremely faint signals, like the radar emissions from an airport on a planet orbiting a star dozens of light-years away. It will map the distribution of hundreds of millions of galaxies, test general relativity in extreme environments, and crucially, it will be the ultimate instrument for hunting techno-signatures and studying anomalies like fast radio bursts. With the SKA, we won't just detect FRBs, we'll study their structure, polarization, and environment in fine detail, which may finally allow us to understand their true nature. The second direction is the development of artificial intelligence and machine learning methods for data analysis. The sheer volume of information generated by modern telescopes is so immense that humans simply cannot process it all. AI algorithms can sift through this data stream in real time, pinpointing anomalies and signal candidates for human review. Furthermore, AI can be trained not only to look for what we expect to find, but also for unknown unknowns, signals that don't fit into any existing categories. This could be the key to discovering the non-human intelligences we've been discussing. The third direction involves coordinated multi-channel observations. When one telescope detects an anomaly, the information is immediately broadcast worldwide, prompting dozens of other instruments, radio telescopes, optical telescopes, X-ray and gamma observatories, and gravitational wave detectors to simultaneously focus on that precise point. This allows us to gather the most complete picture possible and verify if the event has counterparts in other wavelengths. This multi-messenger approach has already yielded breakthroughs such as linking the gravitational wave detection of two merging neutron stars to a short gamma-ray burst. This coordination will only become tighter and faster in the future. The fourth and equally crucial direction is theoretical work. Scientists continue to develop new models of what technosignatures might look like, what secondary effects the activities of highly advanced civilizations might have, and which currently unknown natural phenomena might mimic artificial signals. This work guides observers by defining exactly what they need to search for. So, while we may be stumped on many questions, the work is booming. We are building new, more powerful ears, creating smarter brains to analyze what we hear, and expanding our imagination to be ready for any scenario, no matter how unbelievable. The mystery of interference in cosmic signals is more than just a scientific puzzle. It is a profound challenge to our intelligence, our curiosity, and our place in the universe. And humanity has accepted that challenge. Let's imagine, just for a moment, the most improbable scenario turns out to be true. Tomorrow morning, the headlines scream, "Confirmed, radio signal anomalies are the work of extraterrestrial intelligence." What would that actually mean for us? What would be the fallout from such a monumental discovery? This is the very question explored under the umbrella of the so-called post-contact protocol. Now, there is no single, legally binding international treaty, but there is a series of strong recommendations and agreements developed by the scientific community, most notably by the International Academy of Astronautics. The very first step would be ruthless verification and cross-checking of the data. Any claim of detecting ETI must be corroborated by independent researchers using entirely different instruments. This rigor is essential to rule out errors, hoaxes, or misinterpretation. The infamous Peritons incident, where a false signal was traced back to a microwave oven, taught the scientific community to be extremely cautious. If the signal is confirmed, the next phase is notification. First, the scientific community, then world governments, and finally, the general public through the United Nations. The core idea here is to avoid mass panic and the spread of rumors by delivering the information transparently and from a centralized source. But the most complex and contentious question of all is the response. Should we reply? And if we do, what exactly should we say? Opinions on this matter are radically divided. Figures like the late Stephen Hawking cautioned that any reply would be reckless. We have no way of knowing the other civilizations' intentions. If they can detect our comparatively weak return signal, they are likely vastly technologically superior. A meeting with such a civilization could end for us the way the arrival of Columbus ended for the indigenous people of the Americas, in catastrophe. In this sense, the dark forest hypothesis calls for maximum caution and absolute silence. Others argue that if they have already found us, it is too late to hide. On the contrary, silence might be interpreted as either hostility or cowardice. In this view, it is better to send a response demonstrating our intelligence, our peaceful nature, and our readiness for dialogue. But who gets to decide what message we send? Which nation, which organization will be granted the right to speak for all of humanity? Should we broadcast our scientific achievements, our art, our history? Our history, however, is rife with war and violence. Wouldn't that potentially alienate our cosmic counterparts? These questions have no simple answers. They touch upon the most profound aspects of our politics, our culture, our religion, and our philosophy. The discovery of ETI would spark not just a scientific, but a cultural revolution. It might unify humanity in the face of the other, or conversely, it could lead to new conflicts as different nations or groups attempt to monopolize contact and secure access to alien technologies. The consequences could also be more subtle. What if we received not just a simple greeting, but an entire encyclopedia containing the answers to all our greatest scientific questions? Would this destroy our innate curiosity? What if we learn about civilizations that have existed for millions of years? How would that reshape our religions and our understanding of the meaning of life? For now, these remain purely hypothetical questions. Yet debating them is essential now, because if we truly receive confirmation that someone is out there, we may not have the luxury of endless debate. And how we choose to react to this greatest discovery in human history will determine not only our own fate, but perhaps the destiny of all sentient life in this corner of the galaxy. We've spent a lot of time discussing how we look for them. But let's flip the script. How might they be searching for us? And what technological fingerprints are we leaving across the cosmos that could reveal our presence? Our planet has been noisy in the radio spectrum for nearly a century. The first powerful broadcasts, like the transmission of the 1936 Berlin Olympics, have already left our solar system and are traveling through interstellar space. Those signals are currently about 90 light-years away. This means a sphere 90 light-years in radius surrounds Earth, and within it, any sufficiently advanced civilization could potentially pick up our old radio and TV signals. This sphere is constantly expanding at the speed of light, encompassing thousands of star systems. It's entirely possible someone out there is already catching up on our old sitcoms and Cold War news reports. However, these everyday signals are extremely weak and fade quickly over vast distances. Far more visible are our military radars, particularly missile defense and early warning systems. They emit immensely powerful, focused pulses that can be detected much further out. To an external observer, Earth might look like a faint but constantly pulsating source of radio energy. But that's not our only fingerprint. As astronomy evolves, we've learned to analyze exoplanet atmospheres. When a planet passes in front of its star, its atmosphere absorbs some of the stellar light, and the absorption spectrum tells us about its chemical composition. We look for traces of oxygen, methane, and water vapor, the so-called biosignatures, and that may indicate the presence of life. But an extraterrestrial civilization studying Earth's atmosphere would see more than just biosignatures. They'd see technosignatures. Take chlorofluorocarbons, or CFCs, the synthetic compounds we used in refrigerators and aerosol sprays. These gases do not occur naturally, and their detection would be direct evidence of an industrial civilization. Essentially, we give ourselves away not just by what we broadcast, but by what we breathe out. Now let's return to the idea of intervention. If someone is watching us, they see our progression, from early radio waves to studying exoplanet atmospheres. They might conclude that we are approaching a certain technological threshold, after which we will become highly visible in the galaxy and perhaps a threat. This could be the trigger for intervention. They could try to jam our signals to shield us from others. Or conversely, they might send us a warning sign, disguised as a natural phenomenon, to slow our development or steer it onto a safer course. For instance, a mysterious signal we can't decipher might not be a message at all, but a virus, complex data package designed to compromise our computer networks once downloaded. This sounds like science fiction, yet it's precisely why SETI protocols mandate extreme caution when handling any potential signal. Thus, our own development, our own technological noise, might be the very cause of the anomalies we observe. We are like a teenager who starts blasting music, and now the neighbors are banging on the wall. We don't understand the knock, but it is a direct reaction to our actions. This makes the problem far more complex. We are not merely passive observers, we are active participants in this cosmic dialogue, even if we don't realize it. Every new technological achievement we make, every powerful transmitter we switch on, has the potential to alter the picture we see and provoke a reaction we are currently unable to predict. As our journey nears its end, let's revisit the core paradox underpinning this entire narrative, the Fermi paradox. Named after the physicist Enrico Fermi, who supposedly posed the question to his colleagues over lunch in 1950, the premise is devastatingly simple. Where is everybody? Our Milky Way galaxy contains, by various estimates, between 200 and 400 billion stars. Many of these stars are far older than our Sun, and crucially, we now know that most of them have planets. Even assuming that the conditions for the genesis of life and the development of intelligence are incredibly rare, these numbers suggest there should be thousands, if not millions, of technologically advanced civilizations in our galaxy. Some of them would have emerged billions of years before us. In that time frame, even traveling at a snail's pace, they could have colonized the entire galaxy. We should see the traces of their work everywhere: megastructures, artificial signals, probes in our own solar system, but we see nothing. Space appears empty, sterile, and silent. This is the paradox. There are countless proposed solutions, many of which we've already touched upon. Let's try to organize them into three main groups. The first category: they do not exist. Perhaps we truly are alone. Maybe the creation of life is such an astronomically rare event that it only happened once in the entire universe, right here on Earth. This is the so-called rare Earth hypothesis. Alternatively, life might emerge frequently, but the transition to an intelligent technological civilization is almost impossible. The second category: they exist but we don't notice them. This covers a wide range of ideas. They are too far away. They use technology we can't detect. They are simply not interested in contacting us. They are observing us while maintaining a galactic quarantine. Or perhaps they all perished due to some great filter. An event that wipes out advanced civilizations before they can spread across the galaxy, such as nuclear war, ecological collapse, or a super pandemic. Or, as we have previously discussed, they are deliberately hiding because the universe is a dark forest. The third and most intriguing group for our discussion is: they are here. They have already arrived in our solar system, but we simply fail to notice them. This includes the Sentinel probe hypothesis. Or maybe they are so radically different from us that we are incapable of recognizing them as life forms at all. They might be woven into the very fabric of space-time. And this is where the idea of intervention becomes central. Perhaps the great silence is not the universe's natural state. Perhaps it is artificial. Someone or something is intentionally fabricating this illusion of emptiness. This is the most radical answer to the Fermi paradox. We see no one, not because no one is out there, but because we are prevented from seeing them. The universe isn't silent, it is being silenced. And those anomalies, those strange signals we occasionally pick up, might not be messages at all. They could be cries for help, or glitches in the suppression system, or echoes of a struggle by those attempting to break through the informational blockade. This realization is simultaneously terrifying and hopeful. It suggests we are not alone in our prison, but it also means we are caught within some giant, inscrutable game, the rules of which remain utterly unknown to us. Our next step must be to understand who established these rules and for what purpose. Perhaps by unraveling the mystery of the anomalous radio signals, we will find an answer not just to the question, are we alone in the universe, but to a far more profound one, are we free? We have covered immense ground. We started with the accidental discoveries of Karl Jansky and progressed to the deliberate search for signals using giant radio telescopes. We moved from the simple question, is anyone out there, to complex theories about the galactic internet, the dark forest, and even potential tampering with the very fabric of reality. We have seen how the seemingly simple wow signal could baffle scientists for decades. The discovery of pulsars taught us that nature itself can be the most brilliant trickster. And modern mysteries like fast radio bursts, or FRBs, are forcing us to completely rethink the fundamental tenets of astrophysics. The main conclusion we can draw is both simple and profoundly deep. The universe is not silent. It is filled with sounds, signals, whispers, and screams. Most of these are natural processes, spinning neutron stars, merging black holes, the echoes of the Big Bang. But hidden among this vast cosmic choir might be other voices entirely. The idea that someone is deliberately interfering with this cosmic broadcast is no longer confined to science fiction. It is becoming a viable working hypothesis that offers a new lens through which to view observed anomalies. Is this interference merely a byproduct of super civilizations who simply don't notice us? Or are they hidden messages masterfully disguised as natural phenomena? Or perhaps is it a sinister silence enforced by fear, where rare bursts are just glitches in a system of total cosmic control? We don't have the answer, yet the mere search for it changes us. It drives us to build incredible instruments, to advance artificial intelligence, and to peer into the farthest reaches of space and time. It compels us to collaborate, unifying the efforts of scientists across the globe. Ultimately, the search for extraterrestrial intelligence is a search for ourselves, for our place in this vast, mysterious, and infinitely astonishing cosmos. Thank you for spending this time with me, reflecting on one of the greatest mysteries facing humanity. Don't forget to subscribe to the channel so you don't miss our next journey into the world of science and mysteries. Hit the like button if this topic made you think. Now, I want to ask you a question that has no right answer. Imagine you are that astronomer, the one who receives irrefutable proof that someone is tampering with the signals, that it is not a natural phenomenon. What would you feel in that moment? The elation of discovery? Or a bone-chilling fear? Share your thoughts in the comments below. Good night.